Alright, let's take a look at another gas law problem here. It says a gas occupies a volume of 26.3 milliliters when the pressure is 725 torr. What will the pressure of the gas be? What will the pressure be if the gas is allowed to expand to a volume of 0.351 liters while the temperature remains constant? So this here, the temperature remaining constant, that just means our temperature is not changing. So because our temperature is not changing, it would be the same on both sides of the equation, so we can just ignore temperature. So temperature is not going to be a variable for one of these problems. So first thing we do then after we've read the problem is to identify the variables. The first thing we see is 26.3 milliliters, so that's a volume. And our pressure is 725 torr. And I want to know what the pressure will be when the gas is allowed to expand to a new volume. So now we've got a situation where we've got a new pressure that we're looking for, and our new volume is going to be 0.351 liters. So I go shopping for my my formula that includes P's and V's, and I end up with PV is PV, so P1V1 is equal to P2V2. And we're looking for P2, so to get P2 all by itself, we're going to divide each side by V2. And that's going to cause the V2s to cancel over here. So I can just rewrite this as P2 is equal to P1 V1 over V2. And then we're almost ready to plug everything in. If we do plug everything in, we're going to get some units that are going to be a little strange. We're going to get our pressure being in units of torr milliliters per liter. Nothing's going to cancel. So that means we have a decision. We want our units for volume to cancel. So we can either change this 0.351 liters into milliliters or the 26.3 milliliters into liters. It doesn't matter as long as they're the same units, they're going to end up canceling. I'm just going to change this to milliliters. And to do that, we have to realize that 1 liter is 1,000 milliliters. And 0.351 liters times 1,000, our liters are going to cancel. This is going to be 351 liters. So now we can do a little estimating here. Our volume is getting much bigger. So in order for our volume to increase, our pressure has to decrease because there's an inverse relationship there. All right, so let's plug. I put liters here. That should be milliliters. Sorry about that. Let's plug our numbers in there. So our P2, I'm going to bring this down here, is equal to our P1, which is 725 torr, times our V1, which was 26.3 milliliters. And that's going to be divided by our 351 milliliters that we had there. And we plug that into our calculator. Let's see, 725 times 26.3. Then we're going to divide that by 351. And this should give us a pressure of, let's see, it doesn't look right. Well, yeah, I guess it does look right. So 54.3 torr. At first I said I was kind of not confident about this because this is way smaller than this. Something doesn't seem right. But again, 351 is way bigger than 26. So this turns out to be a reasonable answer. So that's a good way to check yourself. So this is, for those keeping score at home, since we're dealing with pressure and volume, this is a Charles' law problem.